This time we're going to do this one more time. So we did it with a square root, we did it with a quadratic. Now we're going to do it with a very generic linear equation. See how x is, oh, whoops, linear. I already had that down, didn't I? This is just a y equals mx plus b. It really is. See how x is just kind of like x? It's not x squared or no square roots. It's just linear. So we're going to follow everything I taught you about linear on this page. Or I should say reminded you about. The good news is the domain and the range are easy for linear functions. They go left and right forever and up and down forever. Linear always, as long as they're not vertical lines, linear has those qualities to them. Now let's find the equation of the inverse. So the original was y equals 6 minus 4x. Now I got that from up above. So the inverse is x equals 6 minus 4y. And we have to solve for y. So we're going to minus 6 from both sides. And we're going to get x minus 6 equals negative 4y. Those 6's cancel. And now I need to divide by negative 4. So I'm going to have x minus 6 all over negative 4 equal to y. Now that's an okay way of writing it. I would prefer if you remember there's a 1 in front of this and that you make it negative 1/4 x plus 3/2 or plus 1.5. But I guess I will accept both of those as being the inverse equation. So it's like you're dividing each thing by 4. Okay? So if I clear out my calculator and I show you the original, what was the original? 6 minus 4x. And I show you the new one. What was the new one? Let's do the good one. Let's do negative 1/4 x plus 3/2, or plus 1.5 if you prefer 1.5. Now when I hit graph, it's going to graph the original. Now it's going to graph the other one. And if you were to fold these on top of each other, they would fold right into one another. Okay, domain and range of the inverse. So you really just switch these properties. So the domain, remember domain are x values, it's just all real numbers because that's what the y value was. And the range is all real numbers. Y equals all real numbers. Because it just switched the properties from up here. It just so happens that they're the same. Is the inverse a function? Well, remember when we graphed it, it was just a straight line? So yeah, it is a function. All straight lines, as long as they're not vertical lines, are functions. All right, let's see what they want us to do in problem 5. The function d equals 4.9 t squared represents the distance in meters that an object falls, so in this one it would be 24, in t seconds, so how long, due to Earth's gravity. Find the inverse of this function. How long in seconds does it take for a cliff diver to reach the water below? Now, I'm actually not going to find the inverse of this function because I think we could probably just plug 24 in and resolve. So 24 is going to be the distance. Sometimes people make things more difficult than what they need to. Divide each side by 4.9. We just had to know that 24 was a D to plug it in. So let's see, we get 24 divided by 4.9. Is it icky? Yeah, it's pretty bad. It's 4.89796. How about we do quite a few decimals? 89796 equals t squared. Now just take the square root of that. And we'll just round to the nearest tenth. When you take the square root of that to solve for t, you get 2.2, I'm rounding, seconds equals time. And that's how long it takes, if this was somebody diving off a cliff, it would take them 2.2 seconds to reach the water below. So we could have wrote the inverse equation, but quite frankly, I think this was probably just as easy. All right, last page, I promise. This last page is trying to teach you something, kind of a lofty idea, but it is kind of neat. They're saying if you have the original and the inverse, and you do the composition, remember that's what that open circle means? if you do the composition of them, of a certain number, you will get that certain number as an answer. Okay? So let's just see it played out. All right? Problem 6. What is each of the following based on these these questions? This is the original. Maybe we want to write original up here. And they want us to find the inverse. So just like yesterday and the problems we did above, switch x and y and resolve. So the original was y equals 1 over x minus 1. So the inverse is x equals 1 over y minus 1. Multiply both sides by y minus 1. And what that's going to do is cancel this y minus 1 out. So we have y minus 1 equal, in parentheses, times x, I apologize for that equal sign, equals 1. Divide both sides by x, and we get y minus 1 equals 1 over x. Add 1 to both sides, and we get y equals 1 over x plus 1. This is the equation of the inverse. Just had to use your Algebra 1 skills to move the equation around a little bit. Part B. They want us to do the composition with a 5. So when it's written like this, you plug 5 into your inverse equation first. So I'm going to take my inverse equation, I'll do it in blue, and I need to plug in 5. So I'm going to do 1 over 5 plus 1. And that is going to equal 1.2. Now they want me to take 1.2 and plug this into the original. Oh, I'm sorry. Remember this symbol stands for composition. We did that yesterday a few times on the notes, a composition. So here, let's plug 1.2 into the original. So y equals 1 over 1.2 minus 1. Well, that's 1 over 1.2 minus 1 is 0.2. And 1 divided by 0.2 is 5. So here, remember how I told you there's like this lofty idea up here? All this rule is saying is that if you take any number like 5 and you plug it into the inverse, and then you plug that answer into the original, you will get the number that you plugged in as a final answer. That was a lot. We're going to try it one more time. Oh, and we're going to switch it to prove that it's still true. So this time they want us to take 5 and plug it into the original. So I'm going to do y equals 1 over 5 minus 1. This is the original they want first. So that's 1 over 4, or just 1/4. Now they want us to take 1/4 and they want us to plug it in to the inverse. So this equation here that I'm pointing at in the blue box. So y equals 1 over 1/4 plus 1. Well, if we want to kind of be lazy, why don't we just change it to 1 over 0.25 plus 1. And you can know that that just ends up being 4 plus 1, or if you don't know that, you just type it in, and you will get 5. So again, the emphasis of what they're trying to prove up here is this. If you take a number and you plug it in to the original and then take that answer and plug it into the inverse, you will get the original number you plugged in. So what does B and C prove? If you plug in a number to the original, then that answer into the inverse, you get that number at the end. Right, dot, 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 and vice versa. I'm not going to make you rewrite this whole thing. And vice versa. All right. I'm going to fill in the cube and the cube root for tomorrow's video, but I'll attach it as a new video for 6-8.